In this video, we're going to take a look at one example of hypothesis testing. And this is a common situation in quality control applications. The glass bottle company manufactures brown glass beverage containers that are sold to breweries. One of the key characteristics of these bottles is their volume. GBC knows that the standard deviation of volume is 0.08 ounce. They wish to ensure that the mean volume is not more than 12.2 ounce using a sample size of 30 and a level of significance of 0.01. So let's dissect this problem by determining the given information here. First, it says the standard deviation of the volume is 0.08. So that is basically the sigma, standard deviation of this population of bottles. They wish to ensure that the mean volume is not more than 12.2. So right here is an indication that this test is going to be a one-sided test because it's asking us to check whether the mean volume is not more than 12.2. Not more than 12.2 means basically your alternative hypothesis is going to have either a more than sign or a less than sign, and we'll talk about that. It's definitely not a situation where your alternative hypothesis is not equal to, because that doesn't have any direction. That doesn't ensure that we're checking whether it's more than or less than. So that's not the situation here. That is an indication that our alternative hypothesis is going to have one of these signs. And both of them are fine. We'll talk about it more. 12.2 is the number that we want to check against. So that is our basically mu naught. Using a sample size of 30, n, and level of significance of 0.01, and that is our alpha. So in part A, asking us to identify the null and alternative hypothesis. So here is the first step in any hypothesis testing, where we need to determine the null and alternative hypothesis. Well, the null hypothesis is always having an equal sign. So what we do is mu is equal to 12.2, mu naught. But the alternative hypothesis is going to have a sign of more than, less than, or not equal to. Because the problem is asking us to check the mean volume is not more than 12.2, that means a bottle that has a volume of more than 12.2 is not desirable. This company does not want to see bottles that have volumes of more than 12.2. That is the bad result. That is the bad outcome, right? And typically in quality control applications, we set the undesired result as the alternative hypothesis. So that's why I'm going to have mu greater than 12.2 as my alternative hypothesis, because that is the undesirable result. But at the same time, keep that in mind that you 100% you can have mu less than 12.2 as your alternative hypothesis, and that would be fine as well. But I'm just telling you that in quality control applications, undesired result typically goes into the alternative hypothesis. So keep that in mind. Okay, now that is our null and alternative hypothesis. Now in part B, asking us for identify the test statistic and critical region. This is a one-sided test, so the critical region would be on one side of the normal distribution, as we talked about before. And because this test has the more than sign, it is the situation that we had here. So we're going to have a critical region on the right hand side of the normal distribution. So for part B and C are kind of together because part C is giving us the information about our sample. So for this hypothesis test, what we're going to do, we're going to collect a sample of 30 bottles and we measure their volume. And it looks like the sample mean, and remember sample mean is X bar. Sample mean is 12.23. So we went to the production line, we took 30 bottles and we measured their volume, and the average volume of those 30 bottles is 12.23 ounces. So now, what is the conclusion of the test? So the test statistic is z-score, and that is x bar minus mu naught over sigma square root of n. In this case, x bar is 12.23, mu naught is 12.2. Sigma is given is 0.08, and square root of n is 30, so square root of 30. And if you do the math here, you'll get 2.05. Okay, so we know where what our test stat is. Essentially, we know that on the normal distribution here, where the mean is 0, our test stat is, let's say here, 2.05. We still don't know where is the critical region limit. We need to find that out. And again, because this is a one-sided test, going back a few slides, our critical region is when z-score is greater than z of alpha. So we need to find the z of alpha. Alpha of our test is 0.01. So the critical region is when z of score is more than z of alpha. And z of alpha is z of 0.01, and you can read that from the z table. You will see that it's 2.32, and we already talked about the common z values here. So this is the one that we're using. So looks like our critical region starts at 2.32, essentially a little after our test score here. Right, so it looks like critical region is here, which is 2.32. So we're not in the critical region, basically, since the score of 2.05 is not more than z of alpha of 2.32, we fail to reject the null hypothesis. Failing to reject the null hypothesis means what? The null hypothesis here was saying that the average is 12.2. So we failed to reject that. We essentially, quote unquote, accepting it. Meaning that the sample that we took, the sample of 30 that we took in this average, did not give us sufficient evidence to reject this hypothesis. We're essentially saying that, yeah, the average volume of these bottles is probably 12.2. We cannot reject that. So that's the conclusion of the test. And that is based on the comparison of your z-score with the critical region. And that's how you do a one-sided hypothesis testing.